On August 15th, 1977, a radio telescope in Ohio picked up the most powerful signal ever recorded from deep space. For 72 seconds, something out there was calling us, using the exact frequency meant to speak across the galaxy. The astronomer who discovered it was so stunned, he wrote a single word on the printout: wow. For 48 years, we had no clue where it came from. Until yesterday, Harvard astrophysicist Avi Loeb just released calculations that will send chills through your veins. Because on that very day in August 1977, an object was sitting 600 astronomical units away, aimed directly at Earth. That object is now racing through our solar system at 60 kilometers per second. We call it 3I Atlas, and it's larger than Manhattan. The math doesn't lie. The chance that this is coincidence, just 0.66%. That means there's a 99.4% likelihood that 3I Atlas sent that signal. But here's where it turns terrifying. This thing isn't acting like any comet we've ever known. It's releasing pure nickel, without iron, something only seen in industrial manufacturing. It doesn't have a tail. It has headlights pointing forward. It's aligned perfectly to pass Mars, Venus, and Jupiter. And in just 29 days, on October 29th, it will vanish behind the sun, where we won't be able to see what it does next. Scientists are tearing each other apart over this. NASA insists it's just a comet, but they can't explain the nickel. They can't explain its path. They can't explain why it announced itself. With a nuclear reactor-level transmission 48 years ago, the clock is ticking. We have less than a month before 3I Atlas goes dark, and if Avi Loeb is right about what comes next, everything changes. This is the story they don't want you to hear. If this grips you the way it gripped me, hit that like button, subscribe, because we're going deep. And tell me in the comments where you're listening from, what time it is there, and the strangest thing that's ever happened to you. Chapter 1. The Signal from 3I Atlas, Breaking the 48-Year Mystery. Let me walk you through what Avi Loeb uncovered, because once you see the numbers, once you understand the geometry of what happened in 1977, you'll realize we're not looking at cosmic coincidence. We're staring at something that defies every probability model we've ever built. September 29th, 2025. That's when Loeb published his findings. And the timing matters, because 3I Atlas is approaching fast. What he revealed connects two of the most mysterious events in astronomical history. The WOW signal and this interstellar visitor are not two separate mysteries. They are one and the same, divided by 48 years and hundreds of billions of kilometers. Here's what Jerry Eamon saw that night in August. The Big Ear radio telescope at Ohio State University was doing what it always did, listening to the endless patterns in the cosmic noise. At 10:23 p.m. Eastern Time, it locked onto something. In the constellation Sagittarius, the signal strength spiked. Not a small rise, but a massive surge. The computer printed out the sequence, 6EQUJ5, a code meaning the signal was 30 times stronger than background noise. Eamon reviewed that printout days later. When he saw the numbers, he grabbed a red pen, circled them, and next to it, he wrote one word: WOW. That note became its name, the WOW signal. For nearly 5 decades, it remained unsolved. The signal lasted exactly 72 seconds. That's not random. That's precisely how long it takes Earth's rotation to sweep one point in space across the Big Ear's field of view. Whatever sent that signal wasn't moving. It was fixed in a single spot, broadcasting at 1420 megahertz, the frequency of neutral hydrogen, the most abundant element in the universe. If you wanted to send a signal any intelligent civilization would recognize, you'd use that frequency. It's the cosmic calling card, but here's the part no one could explain. The signal never repeated. Every telescope was pointed back to that same spot in Sagittarius and got nothing. Silence. For 48 years, astronomers kept checking. Each time, nothing, as if something out there said hello once and then went silent forever, until Avi Loeb ran the numbers. Loeb isn't a fringe figure. He's the Frank B. Baird Jr. Professor of Science at Harvard, former chair of the astronomy department, former head of the National Academy's Board on Physics and Astronomy. He's published over 900 papers. He's not some conspiracy theorist in a basement. He is establishment astronomy, or at least he was, until he started asking questions that made everyone else uneasy. The question he asked about 3i Atlas was simple. Where was it in August 1977? 3i Atlas moves in a hyperbolic orbit. That means it's not bound to our sun. It came from interstellar space, passed through our system, and will leave again, never to return. Because its orbit is hyperbolic, we can calculate its position at any point in time, past or future, with extreme precision. The math doesn't lie. The gravitational equations are crystal clear. Loeb traced its path backward. On August 15, 1977, 3i's Atlas was roughly 600 astronomical units from Earth. 1 astronomical unit is the distance from Earth to the Sun, about 150 million kilometers. 600 of those puts it far beyond Neptune, beyond Pluto, in that silent, frozen dark where sunlight is nothing but another distant star. But the shocking part wasn't distance, it was direction. The WOW signal came from sky coordinates of right ascension, 19 hours 25 minutes. That's 291 degrees, and declination 27 degrees. Those numbers mark a fixed direction in space, like latitude and longitude, but on the cosmic sphere. On August 12, 1977, just 3 days before the WOW signal was detected, 3i Atlas was positioned at right ascension, 19 hours and 40 minutes. That's 295 degrees, and declination 19 degrees. Let that sink in. The signal came from 291 degrees right ascension, 27 degrees declination. 3i Atlas sat at 295 degrees right ascension, 19 degrees declination. That's a separation of only 4 degrees in right ascension and 8 degrees in declination. 4 degrees, 8 degrees across the vast scale of the entire sky. That's nothing. The full sky spans 360 degrees around and 180 degrees from pole to pole. We're talking about an alignment where the signal and the object were separated by less than 10 degrees in a cosmic sphere covering tens of thousands of square degrees. Loeb ran the probability. If you pick 2 random directions in the sky, what are the odds they'd align within that narrow window? The answer, 0.6%. That's less than 1 chance in 160. Put another way, there's a 99.4% probability. This was not coincidence. Think about that. An interstellar object drifting for millions, maybe billions, of years across the galaxy just happens to pass within a few degrees of the exact point where humanity detected its only confirmed candidate for an extraterrestrial signal. And it was there, at the exact moment the signal was sent. But Loeb didn't stop there. He asked, what kind of transmitter could possibly generate the WOW signal from 600 astronomical units away? The detected strength of that signal ranged from 54 to 212 Jansky. A Jansky, the unit of spectral flux density used in radio astronomy. At a distance of 600 astronomical units to produce that intensity on Earth, the source would need a power output between 0.5 and 2 gigawatts. 2 gigawatts. That's the output of a massive nuclear power plant, more than the Hoover Dam itself produces. And it wasn't radiating randomly. It was transmitting on one very specific frequency, the hydrogen line, aimed directly toward Earth. Natural astrophysical sources don't behave like that. Pulsars emit across a broad range of frequencies. Quasars, same thing. Magnetars, same thing. Natural radio sources are messy, broadband, chaotic. The WOW signal was narrowband, coherent, targeted. It had every hallmark of an artificial transmission. Now we know where it came from, or at least, where something was when it was sent. The signal also showed a blue shift of about 10 kilometers per second. Blue shift means the source was moving toward us. The Doppler effect pushes light and radio waves toward shorter wavelengths when the emitter is approaching. The WOW signal showed a blue shift consistent, with an object moving toward Earth at 10 kilometers per second. 3i Atlas is now racing toward the Sun at about 60 kilometers per second. The shift is smaller than expected, but it's in the same range, the same order of magnitude. Loeb even notes this in his paper. The velocities aren't identical, but close enough that the connection can't be ruled out. So here's what we're looking at. An object traveling through interstellar space for eons, arriving in the outer solar system during the 1970s, transmitting a powerful narrowband signal at the hydrogen frequency, straight toward Earth. Then, silence. For 48 years it drifts inward, deeper into our solar system, unseen by telescopes, too distant, too faint. until July 1st, 2025. When the Atlas survey in Chile detects a fast-moving object, they realize it's not orbiting the sun, it's passing through. And when they trace its origin, it leads right back to Sagittarius, the same region of sky where the WOW signal first appeared. Every time you add another layer, the coincidence becomes even harder to ignore. Trajectory from the same region, timing matching perfectly, blue shift consistent, power output matching artificial levels, the alignment statistically impossible to dismiss. Each one alone, maybe you could explain away, but together, this is where Loeb's critics stumble, because you can't handwave this. You can't just say it's a comet and expect the questions to stop. The math is public. The orbital data is public. Anyone can verify the calculations. And when you do, you get the same result. Either this is the most extraordinary coincidence in the history of astronomy, or 3i Atlas announced itself to us back in 1977, and we're only realizing it now. But if it's not coincidence, if this object really did send that signal, then we have to ask the next question. Why? Why announce yourself and then fall silent? Why broadcast once and never again? What's the purpose of a greeting that no one follows up on? Unless the signal wasn't a greeting at all. Maybe it was something else. A beacon, a warning, or a test to see if anyone was listening, or maybe the signal was never intended for us at all. Perhaps we were simply caught in the path of a transmission meant for something else. Something nearer, something already within our solar system. That thought alone should unsettle you. Because if 3i Atlas was communicating with another presence, then it isn't alone. And if it isn't alone, the question changes completely. We stop wondering if we're being visited and start asking, how long have they been here, watching, waiting, operating quietly in the spaces just beyond our awareness? Chapter 2. 5 Impossible Anomalies that scream artificial. We need to understand what 3i Atlas is doing right now, because its behavior defies everything we know. It doesn't act like a comet. It doesn't act like an asteroid. It acts like something else. Something we've never seen before. 5 anomalies. That's what Avi identified. 5 independent traits that each strain probability, and together, make chance nearly impossible. When scientists speak of anomalies, they mean deviations. Signs that reality isn't matching the model. 1 anomaly, you study. 2, you question. 5, that's when you either rewrite the textbooks or admit something fundamental is missing. Anomaly 1, the trajectory. Atlas follows a retrograde orbit. It's moving opposite to the flow of the planets around the sun. Most objects in the solar system share the same direction, born from the same ancient disk of gas and dust. Retrograde paths are rare, but not unheard of. Comets from the Oort cloud can approach from any angle, so retrograde motion alone isn't shocking. What is shocking is how precisely that backward path aligns with the ecliptic plane. The ecliptic is the flat sheet where all planets orbit: Earth, Mars, Venus, Jupiter, Saturn, all racing along the same cosmic track. Yet 3i Atlas moves against that flow and still remains almost perfectly aligned within that narrow lane. Its orbital inclination, only about 5 degrees. 5 degrees for an object arriving from interstellar space. That is absurdly precise. If such objects came from random directions, they'd enter at any angle across the sky. But the odds of one aligning within 5 degrees of the ecliptic, roughly 1 in 500, already, we've entered the realm of the improbable. Anomaly 2, the timing. Atlas isn't just aligned. It's arriving at a moment that places it unnervingly close to multiple planets. In cosmic terms, close means tens of millions of kilometers. On October 3rd, 2025, just days from now, 3i Atlas will pass within 29 million kilometers of Mars. That's near enough for orbiting spacecraft to capture detailed images. But Mars isn't the only encounter. The trajectory also brushes near the paths of Venus and Jupiter, not simultaneously, but close enough that its orbit intersects all 3. If you randomize the arrival time of that same trajectory, the odds it would pass this near to Mars, Venus, and Jupiter, about 1 in 20,000. So now we stack probabilities. 1 in 500 for alignment, 1 in 20,000 for timing. Multiply them, and you approach 1 in 10 million odds of this being random. But we're not done. Anomaly 3, the disappearing act. Atlas reaches perihelion, its closest pass to the sun. on October 29, 2025. For most comets, perihelion is the moment of brilliance. Sunlight ignites jets of gas and dust, turning them into cosmic beacons. But not this one, because on that very day, 3I Atlas will be hidden directly behind the Sun from Earth's perspective. No telescope on Earth, no probe in the inner solar system will be able to see it. For weeks, it will vanish from every eye. If you were an interstellar spacecraft and wanted to change your course unseen, this is exactly when you do it. A maneuver at perihelion, using the Sun's gravity to amplify thrust, a technique known as a solar Oberth burn. It's the most efficient way to alter velocity. You get maximum speed change for minimal fuel use because you're deep in the Sun's gravity well. If 3I Atlas makes such a move behind the Sun, we won't know until December. And by then, it could be heading anywhere. That timing feels deliberate. An object drifting for eons suddenly aligns its closest solar pass with the one moment it's invisible to us. Coincidence? Or design? Anomaly 4. The anti-tail. Everyone knows comets have tails. Tails that always point away from the Sun. Pushed by solar wind and radiation pressure. The tail of a comet always points away from the Sun, like a windsock caught in a cosmic breeze. It's basic cometary physics observed for centuries. Utterly routine, but 3I Atlas doesn't follow routine. It doesn't have a normal tail. It has something else. On July 21, 2025, the Hubble Space Telescope captured an image of 3I Atlas. The photo revealed a teardrop-shaped cocoon of dust enveloping the nucleus, but it wasn't symmetrical. There was more material in front of the object, facing the Sun, than behind it. The dust glowed ahead of the nucleus, like headlights cutting through the void. That's backwards. That's wrong. Dust should trail behind. Solar radiation should push it away from the Sun, forming a long, graceful tail stretching into darkness. But instead, there's a glow in front, as if the object itself is lit from within. As if it's emitting something forward. Loeb offered one possible explanation. If the nucleus doesn't spin, if it constantly keeps the same face turned toward the Sun, then one side would remain eternally hot, the other eternally cold. Ice on the day side would sublimate, turning straight from solid to gas, dragging dust with it. If the object isn't rotating, that outgassing would occur only on the front, the Sun-facing side, creating a forward glow instead of a trailing tail. But that theory demands tidal locking, like how the Moon always shows one face to Earth. Tidal locking only happens when an object orbits close to a massive body for a very long time. The larger body's gravity slows the smaller one's spin until the two become synchronized. But 3I Atlas isn't orbiting anything. It's just passing through. There hasn't been enough time for tidal locking. So why would it have stopped spinning? Unless it was designed that way. Unless it's deliberately maintaining a fixed orientation, keeping one side pointed toward the Sun because that side matters. Maybe solar panels, maybe sensors, maybe a transmitter. The glow itself raises another puzzle. Hubble's image shows no prominent tail streaming backward. For a comet already active beyond 4 astronomical units, there should be a long dust trail by now. But there isn't. Or if there is, it's far fainter than it should be. Instead, the light concentrates around the nucleus and in front of it. It doesn't match the comet model. It matches something else. Anomaly. Number 5. The mass problem. On September 25, 2025, Avi Loeb released another paper, this time with Richard Clue and Peter Vey. They analyzed 3I Atlas's path in excruciating detail, using data from 227 observatories worldwide. Over 4,000 observations collected between May 15th and September 23rd. They were searching for signs of non-gravitational acceleration. That's what happens when a comet vents gas. Jets of vapor act like miniature rocket engines, nudging it slightly off course. It's normal behavior for comets. Astronomers measure the deviation over time, compare it to predictions, and calculate the thrust of the escaping gas. Atlas is venting material, a lot of it. The James Webb Space Telescope measured mass loss at roughly 150 kilograms per second. That's a torrent, a fire hose of vapor streaming into space. With that kind of outgassing, you'd expect measurable acceleration, tiny orbital shifts from the jet's thrust. But Loeb and his team found none, 0.3. Atlas's motion follows pure Newtonian gravity within the limits of measurement. Despite losing 150 kilograms per second, it isn't accelerating. That means only one thing. It's too massive to move. The gas jets are nothing compared to its inertia. When you run the numbers, mass loss rate versus acceleration limits, you get a minimum mass of 33 billion tons. 33 billion. That's the mass of a mountain. If made of solid rock or ice, that would mean a diameter of at least 5 kilometers, 5,000 meters. If 3I Atlas is a solid body that size, it's enormous, far larger than any interstellar visitor we've seen before. Oumuamua, the first interstellar object discovered in 2017, was only a few hundred meters long. Borisov, found in 2019, had a nucleus maybe half a kilometer wide, while Atlas dwarfs them both, 10 times the diameter, 1,000 times the volume, 1,000 times the mass. But here's the statistical problem. Smaller objects are vastly more common than large ones. In the asteroid belt, the Kuiper belt, interstellar space, the size distribution follows a power law. For every giant, there are thousands of smaller rocks. We've detected 3 interstellar visitors so far. 2 were small. Now suddenly the third is 5 kilometers wide. That's backwards. We should have seen hundreds, thousands of smaller ones first. The odds of discovering a 5-kilometer object in a sample of 3 are astronomically low. Unless 3I Atlas isn't random. Unless its size isn't coincidence. Unless it was built that way. Massive because it needs to be. Because it carries something. Because it has a purpose. Put all 5 anomalies together. The ecliptic alignment, 1 in 500. The planetary encounters, 1 in 20,000. The hidden perihelion. The forward-facing glow, the impossible mass, each on its own is improbable. Together, they form a pattern, and patterns are what we search for when we search for intelligence. Think about crossing a street. If there's even a 40% chance a car could hit you, you watch that car. You don't assume it's fine. You pay attention. That's where we are with 3I Atlas. The anomalies are stacking. The probabilities are collapsing. And in just days, we'll get our closest look yet. Cameras orbiting Mars will soon capture images 100 times sharper than anything before. We'll finally see the nucleus, separate from the haze. We'll know if it truly spans 5 kilometers, or if it's something else entirely. And what we discover might change everything we thought we knew about what's possible. When scientists study a comet, they uncover its secrets through light, the light it emits and reflects. This process is called spectroscopy, breaking light into a rainbow spectrum to reveal hidden fingerprints. Each element, each molecule, leaves its unique signature. Sodium glows yellow, hydrogen radiates red, and water reveals itself through distinct infrared bands. By examining which wavelengths appear and which vanish, astronomers decode a comet's chemical makeup. Comets are usually simple, a blend of ice and rock, mostly frozen water mixed with carbon dioxide, carbon monoxide, methane, ammonia, and dust grains of silicates and organic material. As they drift closer to the sun, that ice vaporizes, turning straight from solid to gas, dragging dust into space and forming the glowing tail we see. By studying the light from that gas and dust, we learn what the comet is truly made of. But 3I Atlas, the third known interstellar visitor, doesn't play by those rules. Since its discovery, it has been studied by the Hubble, Webb, and even the Very Large Telescope in Chile. Each observation adds another piece to a puzzle that simply doesn't fit. The James Webb Space Telescope observed 3I Atlas on August 6, 2025. Using its powerful near-infrared spectrograph, Webb detected the usual suspects: carbon dioxide, water, carbon monoxide, and carbonyl sulfide. But their ratios were completely upside down. 95% carbon dioxide, only 5% water, and faint traces of the rest. That's the reverse of every known comet in our solar system. Normally water dominates. It's the most common volatile substance out there. Finding a comet made almost entirely of carbon dioxide is like finding a human made of 95% bone and only 5% water. Chemically bizarre. NASA, astrochemist Stephanie Milam, suggested that cosmic rays may have altered the surface during its long journey through interstellar space. High-energy particles, racing through the galaxy at near light speed, could have bombarded the surface ice, transforming water into carbon dioxide and other compounds, leaving behind a cooked shell. It's a clever idea, but it has problems. Cosmic rays only affect the surface, not the interior. As the comet heats up, that surface layer should blow away, exposing untouched ice beneath, and the spectrum should change over time. But it doesn't. 3I Atlas has been active for months, and its carbon dioxide levels aren't dropping, they're rising. And then there's the comparison. The previous interstellar comet 2I Borisov looked normal, water-rich, with standard ratios. If cosmic ray cooking is universal, why does Borisov look ordinary while Atlas looks alien? The chemistry doesn't quite add up. Maybe 3I Atlas formed in a different kind of planetary system, one rich in carbon dioxide and poor in water. It's possible but rare. Water is common everywhere, because hydrogen and oxygen are everywhere. To get a CO2-rich object, you need very specific, unlikely conditions, or perhaps it's not natural at all. Maybe that carbon dioxide isn't escaping ice. Maybe it's being released on purpose. After all, carbon dioxide is used as a propellant in spacecraft thrusters. It's stable, easy to store, and produces thrust without a bright exhaust. If 3I Atlas were some kind of artificial object, venting carbon dioxide would be a clever, subtle way to maneuver. Of course, that's just speculation, but it's a possibility that lingers as the mysteries deepen. And then, another anomaly. On August 25, 2025, the Very Large Telescope in Chile captured the ultraviolet spectrum of 3I Atlas. The results stunned the team led by Rohan Rahat Gamma and Thomas Pouzier. They detected 22 clear emission lines, all from nickel atoms glowing under solar ultraviolet light. Nickel itself isn't shocking. Comets contain metal dust. But here's the twist. They found nickel and no iron. In normal comets, nickel and iron always appear together. Twin metals born from the same cosmic dust. But in 3I Atlas, the iron is missing. Another mystery, another rule broken. Another sign that this is not a comet as we understand it. Iron and nickel, two metals born together in the hearts of dying stars. When a massive star ends its life in a supernova, the explosion forges both elements in nearly equal amounts. From that cosmic blast, entire worlds are seeded. Planets, asteroids, and comets all inherit this elemental balance. Every natural rock we've ever studied, from meteorites to comets, carries both nickel and iron. Sometimes one dominates, sometimes the other, but both are always there. Always, until now. In 3I Atlas, something is missing. The spectrum from the Very Large Telescope shows clear, strong lines of nickel, but no trace of iron. The iron lines that should be there are simply gone. The team searched carefully, scanning multiple wavelengths. Nothing. If iron were present in normal amounts, it would have appeared easily. It didn't. It's not there. Lead astronomer Thomas Pouzier said, "This opens a door to a whole new world of chemistry we've never had access to before." He's right. But the question is that new chemistry natural or artificial? Because on Earth, nickel without iron is not random. It's manufactured. Industrial refining separates nickel from iron ore using chemical processes. One of them, the Mond process, relies on a compound called nickel carbonyl. When carbon monoxide reacts with nickel, it forms a gas that can later be heated and broken down, leaving behind pure nickel metal. It's how we make high-grade nickel alloys, materials used in jet engines, spacecraft structures, and advanced engineering. In short, nickel without iron is a signature of technology. And that's exactly what 3I Atlas is shedding, in increasing amounts. When it was first detected in July, about 3.9 astronomical units from the Sun, the nickel signal was faint. By late August, as it closed to 2.8 AU, that signal had grown 25-fold, 25 times more nickel in just 1 month. The closer it gets to the Sun, the stronger the emission becomes. But what's even stranger is how fast it grows. The team modeled the data and found the nickel production rate increases as distance to the power of -9, a relationship so steep it defies typical comet behavior. Normal comet activity scales as distance to the power of -2 or 3. -9 means something is changing at an extreme, almost engineered pace. Why would nickel output rise so dramatically? Maybe the surface is layered, rich in nickel, poor in iron, and as it erodes, it reveals more of the same material. But that still doesn't explain the missing iron. Another theory, nickel carbonyl gas. Nickel carbonyl is highly volatile. It vaporizes at very low temperatures, much lower than water ice, and could start escaping even when far from the Sun. As the object warms, the gas production would skyrocket, releasing free nickel atoms that glow under sunlight. It's chemically plausible, but here's the problem. Nickel carbonyl has never been detected in any natural comet, ever. Not in the solar system, not in interstellar space. If it's really there, where did it come from? Nickel carbonyl forms when carbon monoxide reacts with metal under very specific temperatures and pressures, conditions not easily found in the cold emptiness of space. Unless, of course, it wasn't formed naturally. And then came another twist. In early September, astronomers Michael Jerger and Gerald Roman observed 3I Atlas changing color. Its glow shifted from a reddish hue to a vivid green. That color usually means cyanide, carbon and nitrogen molecules fluorescing under sunlight. Around the same time, the Very Large Telescope recorded a sharp increase in cyanide production, rising in sync with the surge in nickel output. Two signals, nickel and cyanide, both ramping up together, both highly unusual, both unlike anything we've seen in natural comets. Each new observation adds another layer to a pattern that refuses to fit the old model. To explain it, scientists must stack more and more unlikely assumptions. Rare chemistry, exotic conditions, one coincidence after another. At some point, you have to ask, are we looking at an impossibly strange comet? Or are we looking at something that was never a comet to begin with? The Loeb scale. How dangerous is it? When Avi Loeb first suggested that 3I Atlas might be technological, he knew he needed a way to measure risk, a framework to separate scientific caution from hysteria. So he created the Loeb scale, a ranking from 0 to 10, designed to express both the likelihood and potential danger of an interstellar object being artificial. Level 0 means definitely natural, an object consistent with known comets or asteroids. 2I Borisov, the previous interstellar comet, was a perfect 0, looked like a comet, acted like a comet, and contained the chemistry of 1. Level 10, however, represents the opposite extreme, a confirmed artificial object on a collision course with Earth, capable of global catastrophe, the kind of event humanity might not survive. Between 0 and 10, the scale rises through increasing levels of anomaly and threat. Level 1, minor deviations, inconclusive data. Level 2, odd features still explainable by natural means. Level 3, persistent, repeating anomalies that start to challenge what we know. Where 3I Atlas stands. Now, according to Avi Loeb, Level 4 marks the point where things stop being comfortably explainable. It means multiple anomalies, all difficult to justify through natural processes. Patterns begin to emerge, patterns that whisper of a possible artificial origin, though not yet confirmed. Right now, Loeb estimates the odds this way: 40% technological, 60% natural. Think about that for a second. If you were about to cross a street and someone told you there's a 40% chance you'll be hit by a car, would you step forward? No, you'd stop. You'd watch. You'd take the threat seriously. Even though it's more likely that nothing happens, the risk is too high to ignore. Level 5 would be reached if new evidence tips the balance, if those anomalies grow stronger, clearer, undeniable. When we can no longer explain the behavior of 3I Atlas through any known natural process, the probability crosses 50% and the alarm level rises. Level 6 represents an object that is very likely artificial, supported by multiple independent lines of evidence, though not yet proven beyond reasonable doubt. At Level 7, the debate is over. We are no longer speculating. We are witnessing confirmed technology. The object maneuvers intentionally. It transmits signals. It displays geometry and motion that nature simply doesn't produce. At that point, the question changes from, is it artificial? To what kind of technology is it? And what does it want? Level 8 describes confirmed artificial objects that pose no immediate threat. Perhaps a flyby probe, silently observing us from a distance. Still a world-shattering discovery, but not an existential one. Level 9 is where things turn deadly. A confirmed artificial body on a trajectory capable of regional destruction, the equivalent of a large-scale nuclear strike, enough to annihilate a city or a nation. And Level 10, the top of the scale, means a confirmed artificial object on a collision course with Earth, an extinction-level event. For comparison, the asteroid that wiped out the dinosaurs was about 10 kilometers wide. 3I Atlas might be half that size, moving at 60 kilometers per second. If it ever struck Earth, the impact would unleash energy equivalent to millions of nuclear warheads. The resulting dust cloud would choke sunlight for years, global temperatures would collapse, agriculture would fail, human civilization might not survive. Fortunately, 3I Atlas isn't on a collision course. Not yet. Its current trajectory keeps it roughly 1.8 astronomical units away. That's 270 million kilometers, farther than the distance from Earth to the Sun. So even if it's artificial, even if it has hostile intent, it's not aimed at us, for now, but trajectories can change. And that's why the perihelion maneuver matters. If 3I Atlas performs a propulsive burn while hidden behind the Sun in late October, it could alter its course. Loeb's team calculated that a velocity change, a dV, of just 30 to 40 km/s could redirect part or all of the object toward Earth, arriving between late December 2025 and early January 2026. 30 to 40 km per second is beyond what chemical rockets can do, but not impossible for ion drives, nuclear propulsion, or more advanced systems. And if 3I Atlas has crossed the stars, it must have some form of propulsion, something that sustained it over interstellar distances. If that burn happens, if its path changes, we might have only weeks of warning. Detection would depend on reflectivity, timing, and whether our telescopes even happen to be looking in the right place. That's not enough time to mount a defense. We can barely deflect small asteroids, let alone something traveling at interstellar speeds. So when Loeb calls level 4 a yellow alert, he's not exaggerating. It means we're dealing with something anomalous, active, and demanding attention, something that could escalate fast if the pattern continues. The dark forest hypothesis, 2. Understand what this might mean. Loeb points to a chilling idea. The dark forest hypothesis, a possible answer to the Fermi paradox. Why, in a galaxy full of stars and habitable worlds, haven't we heard from anyone else? The hypothesis, popularized by author Liu Cixin, imagines the universe as a vast, silent forest. Every civilization is a hunter moving carefully through the darkness, alert, cautious, armed. The forest is full of others, but you can't see them. You don't know their intentions. And if you reveal your position, you risk being eliminated. Because in this cosmic forest, resources are finite. Every civilization that grows will one day need more. More territory, more energy, more safety. And when two hunters meet, each faces the same choice: cooperate or eliminate the other before they become a threat. But cooperation requires trust, and trust requires communication. And communication takes time, sometimes decades, even centuries at light speed. Meanwhile, the other civilization could be building weapons or moving closer. So the safest strategy is to strike first. That's the brutal logic of the dark forest. Over eons, civilizations that make noise get destroyed. Those that stay silent survive. The result is a galaxy full of quiet, paranoid worlds, each hiding from the others. It's a terrifying thought. If it's true, then first contact won't be a moment of peace or enlightenment. It might be a preemptive strike, a civilization detecting us and deciding to erase us before we can pose a threat. History supports the pattern. Whenever an advanced civilization meets a less advanced one, the outcome is rarely kind to the latter. Colonization, conquest, extinction. Earth's history repeats that lesson over and over. So if 3I Atlas is a probe, or worse, a mothership, the question becomes, what is its purpose? Is it observing us, communicating, evaluating whether we're dangerous? Or is it preparing for something else entirely? Loeb has suggested 3I Atlas might be a carrier, releasing smaller probes as it passes through the solar system. Reconnaissance drones, perhaps. Or something with more intention. Its trajectory supports the idea. It passes close to Mars, Venus, and Jupiter, ideal positions for deploying smaller craft. A probe launched toward Mars from 3I Atlas would need only a few kilometers per second of thrust to reach it. Even simple chemical propulsion could do that. Earth, however, is trickier. 3I Atlas never comes close enough for a direct intercept unless it maneuvers near the Sun. A small course correction could release probes toward us, or perhaps it already has. We wouldn't know. Our telescopes can't detect objects smaller than about 100 meters across at interstellar distances. If something that small is already inbound, we wouldn't see it until it was far too late. That's why Loeb's Galileo project is watching. The project operates observatories across the US, in Massachusetts, Pennsylvania, and Nevada, equipped with optical and infrared sensors designed to detect unidentified aerial phenomena. They can spot and track any object that doesn't behave like a satellite, an aircraft, or a meteor. An alien probe, by contrast, would stand out immediately, maneuvering against gravity, changing velocity, reflecting light in unnatural ways. If such a probe entered near-Earth space, we could detect it, assuming we're looking in the right place, at the right time. But detection is only the beginning. If we do find something, what then? Do we attempt communication? Do we capture it? Do we treat it as a threat? Right now, there are no global protocols for responding to alien technology. No defense plan, no chain of command, just silence, and a growing sense that something extraordinary and possibly dangerous has already entered our skies. October the 29th. That's when everything changes. The perihelion passage, the moment when 3I Atlas swings closest to the Sun, is the single most critical point in its journey. It will be at its most active, its most heated, and hidden from our view, lost behind the solar disk. If 3I Atlas is going to do something, to maneuver, to deploy, to reveal its true nature, this is when it will happen, and we won't know. Not until December, when it re-emerges from behind the Sun. By then, if probes have already been released, they could be en route to Earth, or to other targets across the inner solar system. That's why Loeb warns, the time to prepare is now, not after the fact. Chapter 5. The Mars Encounter, October 3rd. This week, right now, as you listen, 3I Atlas is approaching Mars. Within days, maybe even hours depending on when you hear this, the object will pass within 29 million kilometers of the red planet. That might sound like an enormous distance, but in astronomical terms, it's incredibly close. Close enough that the spacecraft orbiting Mars will be able to capture images with unprecedented clarity. The key instrument. HiRISE. The High Resolution Imaging Science Experiment aboard NASA's Mars Reconnaissance Orbiter. HiRISE is one of the most powerful cameras ever sent to another world. It was designed to scout landing sites for Mars rovers, capable of resolving objects just 1 meter across from orbit. But on October 3rd, HiRISE won't be looking at Mars. It'll be aimed directly at 3I Atlas. From a distance of 29 million kilometers, it will achieve a pixel resolution of roughly 30 kilometers per pixel. That means each pixel in its image will represent a patch of the comet's surface about 30 kilometers wide. That might not sound impressive, but for an interstellar object moving at 60 kilometers per second, it's revolutionary. No spacecraft has ever gotten this close to a visitor from another star. When Oumuamua passed through in 2017, we only noticed it after it had already swung past the Sun and was on its way out. We captured nothing more than faint, blurry images from ground-based telescopes. Not enough to see shape, surface, or detail. 2I Borisov gave us more, but still, all observations came from Earth. Resolution was limited. Atlas is different. We have spacecraft in position, near Mars, and the object is coming right by them. For the first time in history, we'll obtain a resolved image of an interstellar object. We'll be able to distinguish the nucleus from its glowing coma. We'll see the shape, the texture, the brightness. And if the surface shows patterns, regularity, geometry, anything that looks engineered, HiRISE will see it. What are we looking for? First, the size. Current estimates for the nucleus range between 0.5 kilometer and 5.5 kilometers in diameter. That's a huge margin of uncertainty. HiRISE will help narrow it down, measuring the amount of reflected sunlight, then calculating surface area based on its albedo or reflectivity. From that, astronomers can estimate diameter and volume. If the nucleus turns out to be at the larger end, 5 kilometers or more, That creates a major statistical problem. Finding such a large interstellar object this early in our search is highly improbable. It would strengthen the argument that 3I Atlas isn't random, but deliberately constructed. Second, the shape. Natural comets are messy. They're jagged potato-shaped rubble piles, loose collections of rock and ice held together by gravity, their surfaces scarred by billions of years of impact. But if 3I Atlas turns out to have a regular shape, if it's spherical, cylindrical, or shows flat planes and sharp edges, that's a serious red flag. Artificial structures have geometry that nature rarely produces. Think back to Oumuamua. Its shape was strange, elongated, with a length-to-width ratio of about 10:1. Some saw it as a cigar, others a thin, flat light sail propelled by sunlight. But the data was too blurry to decide. This time, we'll see clearly. If high-rise, images reveal a symmetrical or geometric form, something precise, something engineered, it will be impossible to ignore. Third, the dust cloud. High-rise should also reveal how the dust is distributed around the nucleus. Is it smooth and even, or does it cluster in specific directions, showing jets or plumes erupting from the surface? Comets often have active regions, points where subsurface ice vaporizes, creating geyser-like jets of gas and dust. But if 3I Atlas shows plumes that don't align with solar heating, jets pointing sideways or against the sun, that would suggest active maneuvering, not natural outgassing. Another anomaly, another piece of the puzzle. Fourth, precursor objects. This one is speculative, but vital. If 3I Atlas has released smaller probes, and if those probes are already ahead of the main body, moving toward Mars, HiRISE might be able to detect them. Ground telescopes can't spot objects smaller than 100 meters from that distance, but HiRISE, from orbit, can, if they're reflective enough. Loeb's team calculated that if a probe had been ejected roughly 30 million kilometers ahead and sideways toward Mars, it could reach the planet around the same time as the main object's closest approach. A probe moving just a few kilometers per second relative to Atlas could easily make that journey in the weeks since the object became active. Would HiRISE see it? Maybe. It depends on size, reflectivity, and timing. But if it does detect something, a separate, smaller body on a deliberate trajectory, then everything changes. That would confirm technology, and 3I Atlas would immediately jump to a much higher Loeb scale classification. The supporting observations, ESA's Mars Express and ExoMars Trace Gas Orbiter, are also observing 3I Atlas during this encounter. Mars Express carries a high-resolution stereo camera and multiple spectrometers. ExoMars adds the color and stereo surface imaging system and the Nomad spectrometer. Together, they'll measure the spectrum of light emitted and reflected by the object's coma, searching for molecular fingerprints, water, carbon dioxide, carbon monoxide, methane, ammonia, and a range of organic compounds. By comparing these Mars orbit spectra with the ones gathered by Webb and by Earth-based telescopes, scientists will build a complete chemical profile of 3I Atlas if new molecules appear, or if the ratios shift as the object heats up. That will tell us how its chemistry evolves near the sun. The object will still be faint and far, so the images won't be dramatic. It will appear smaller than a single pixel in most cameras, but the spectral data may still reveal crucial clues, especially if the coma brightens. Observations are scheduled between October 1st and October 7th, with closest approach on October 3rd. By the time you hear this, those observations may already have taken place. The data will soon be transmitted to Earth, processed, analyzed, and within weeks, the world will know what Mars saw. An intelligent adversary changes everything. But there's another possibility to consider. What if 3I Atlas isn't maneuvering toward Earth at all? What if its true destination is Jupiter? After its perihelion, the object's projected path brings it relatively close to Jupiter. A modest change in velocity, just 10 to 15 kilometers per second, could redirect its course, bringing it far nearer to the gas giant than current predictions suggest. Close enough to observe Jupiter and its moons in remarkable detail. close enough to release probes into the planet's upper atmosphere, or even land them on the icy surfaces of Europa, Ganymede, or Callisto. These moons have long fascinated astrobiologists, especially Europa, which hides a vast ocean beneath its frozen shell. It's one of the most promising places in our solar system where life could exist. If an alien civilization were searching for biological activity here, Europa would undoubtedly be near the top of their list. A probe sent there could be hunting for the same things we are: microbes beneath the ice, chemical traces of metabolism, any evidence that life exists beyond Earth. But then, what happens if 3i Atlas finds it? Would it transmit its discovery back to whoever sent it? Would it collect samples? Or worse, could it interfere, altering ecosystems, contaminating pristine environments? We simply don't know. That's the core problem. A civilization capable of sending probes across interstellar distances operates with motives and intentions we can barely comprehend. They might be scientists, curious explorers seeking knowledge. They might be resource surveyors, cataloging worlds for future use. Or they could be exterminators, removing potential threats before they ever emerge. This is the unsettling premise of the dark forest hypothesis, a universe where survival depends on silence. In such a cosmos, revealing your presence can be fatal. If 3i Atlas is indeed a probe from that kind of civilization, its mission could be simple: observe, assess, and, if necessary, eliminate. It sounds like science fiction, paranoid even, but history tells a darker story. Whenever an advanced civilization encounters a less developed one, the outcome is almost always tragic for the weaker side, and there's no reason to believe the same rule wouldn't apply on a cosmic scale. Dr. Loeb doesn't claim to know what 3i Atlas truly is, only that we shouldn't dismiss the possibility of technology without proper investigation. And now, everything hinges on October 29th, its perihelion passage. That moment will be the ultimate test. If this object is going to do something extraordinary, something no comet or asteroid ever could, it will happen then. But here's the twist: we won't be able to see it. During the critical window, 3i Atlas will be lost behind the sun, completely invisible to our telescopes. All we can do is wait. When it re-emerges in late November or early December, scientists will recalculate its path, searching for any deviation from its predicted orbit. If it stays perfectly on track, the technological hypothesis weakens. But if it isn't where it should be, if its orbit has shifted in ways that require thrust, then we'll have our answer. And then, the real questions begin. Questions about how humanity should respond. Do we attempt communication or prepare for defense? Can we unite in the face of a possible external threat? Or will we fracture into rival factions, arguing over the right course of action? These are questions we've never truly faced. Because until now, alien visitors were only theoretical. But 3i Atlas changes that. It makes the possibility real. In less than a month, we'll know more. We'll have data from the Mars flyby. We'll observe its behavior as it nears the sun. And then, when it vanishes behind the solar disk, we wait, we watch, and we hope that when it reappears, it's still just a comet, but we must also be ready for the possibility that it's not. 17-minute intervals, allegedly detected by radio telescopes. Reports claim that 3i Atlas is emitting pulses, precise bursts of energy every 17 minutes. But so far there's been no official confirmation. Still, 17 minutes is oddly specific. It's not a round number, and it doesn't match any known natural rhythm. No rotation cycle, no orbital resonance. If these pulses are real, they would be incredibly difficult to explain through natural physics. Pulsars emit regular radio signals, yes, but pulsars are neutron stars. Their pulses measured in milliseconds or seconds, not minutes. 17-minute pulses from a small interstellar object. That would require something active, something intelligent, a mechanism turning on and off with machine-like precision. It could be a beacon, a positional signal, or even a data transmission, packets of information broadcast across the void at fixed intervals. But we must tread carefully. Radio astronomy is delicate work. Human interference, from satellites, transmitters, even ground equipment, can create false positives that look eerily like signals from space. Distinguishing true extraterrestrial communication from background noise demands rigorous verification. That's what made the famous "wow" signal so extraordinary. It passed every test, duration, frequency, strength. Everything consistent with an intelligent source. The same standard must apply here. If the 17-minute pulses are genuine, they must be confirmed by multiple independent observatories before anyone can take them seriously. Now, another theory is spreading. One not about what's being detected, but about what's being hidden. Many are asking, why is so little information being released about 3I Atlas? NASA and other space agencies have remained unusually quiet. Yes, there are official statements, basic data about its orbit and composition. But beyond that, the silence feels deliberate. Some interpret this as a cover-up, a calculated effort to withhold information to prevent public panic. But there's a simpler explanation. Science takes time. Researchers are cautious. They don't publish results until the data has been analyzed, verified, and reviewed. Every observation passes through a long chain: collection, processing, error checks, paper writing, peer review, publication. It's a process that takes weeks, sometimes months. The Mars-based observations on October 3rd only just occurred. The data is still being processed. Instant answers aren't realistic. Yet in a world of real-time updates and viral speculation, slow science feels like secrecy. And that perception fuels the fire. Then comes the NASA Juno question. Why hasn't NASA redirected its Juno spacecraft to intercept 3I Atlas next March? Technically, the maneuver is possible. Juno is nearing the end of its mission. The scientific payoff from even a brief flyby of an interstellar object could be immense. So why the hesitation? Some blame bureaucracy, NASA's complex web of committees and approvals. Even a small mission adjustment demands layers of sign-off. Others point to budget constraints. If Juno diverts course and the encounter reveals nothing, someone has to answer for the expense. But conspiracy circles have a darker take. They believe NASA doesn't want Juno anywhere near 3I Atlas, that it knows something dangerous. Perhaps they fear contamination, that the object might harbor unknown biological or chemical hazards, or maybe they fear damage, that Juno itself could be destroyed if the object is hostile, or the most unsettling theory of all, that NASA already knows what Juno would find, and that discovery would be impossible to keep secret. To be clear, there is no evidence supporting this. The logical explanation is still the simplest. NASA is following standard procedure, carefully balancing risk, reward, and resources. But perception matters. When people believe they're not being told the truth, they fill in the blanks themselves. And what fills those blanks can be terrifying. One of the more outlandish ideas making the rounds is what some call the Epstein Files distraction theory. According to this claim, the sudden attention around 3I Atlas is a deliberate diversion, a manufactured alien scare meant to shift focus away from scandals, political instability, or other global troubles. Dr. Loeb addressed this directly in one of his blog posts. He pointed out a simple, verifiable truth. 3I Atlas is real. It can be seen by anyone with a decent telescope. It moves. It reflects light. It follows a measurable path through space. It's not fabricated, not projected by satellites, and not created by some mythical space laser. The object is real. The trajectory is real. The anomalies are real. Whether those anomalies point to alien technology is a question of science, not politics. Still, conspiracy thrives in the soil of distrust. People who've been lied to before won't suddenly start believing now. They assume deception. They assume hidden agendas. They assume the worst. Some even insist that 3I Atlas itself is fake. A government fabrication designed to prepare the public for a staged alien event or justify new surveillance powers. Old conspiracy tales like Project Bluebeam have been resurrected, repurposed, and attached to 3I Atlas. But this theory collapses under scrutiny. Multiple observatories around the world have tracked the object. Amateur astronomers have imaged it. Its motion can be verified by anyone with the right equipment. To fake that would require a global conspiracy involving thousands of scientists across dozens of countries. That level of coordination is impossible. Occam's razor gives the obvious answer. The object is real. But for those who distrust everything, no evidence will ever be enough. They'll claim the images are doctored, the data fabricated, the scientists complicit. Once you go that deep, logic no longer applies. There's also a quieter, subtler theory. one not born from fear, but from interpretation. It suggests that 3I Atlas, real or not, is being used as part of a psychological preparation, a slow acclimation of humanity to the idea that we are not alone. Disclosure by degrees. First, we find exoplanets. Then, we detect biosignatures in distant atmospheres. Then, an interstellar object appears with strange, unnatural traits. Each revelation builds on the last, easing us toward the ultimate truth. Some see this as progress, a deliberate path toward acceptance and understanding. Others see danger, a transformation that could shatter beliefs, religions, and worldviews. Because if humanity learns, undeniably, that we are not alone, everything changes. And through all these theories, wild or reasonable, one haunting question lingers. If 95% of the world doesn't even know 3I Atlas exists, is that because the truth is being hidden, or simply because most people aren't paying attention? Probably the latter. Astronomy rarely makes headlines, not unless the threat feels immediate, but that could change in an instant. If 3I Atlas maneuvers, if it emits signals, if probes or technology are confirmed, then it will dominate every screen on Earth. And when that moment comes, the conspiracy theories will multiply beyond control, because suddenly, the unknown will no longer be distant, it will be here. The academic bloodbath. Science is meant to be objective, dispassionate, following evidence wherever it leads, testing every hypothesis with rigor, and accepting the truth whether it confirms or shatters expectations. That's the ideal. But science is done by humans, and humans have egos, reputations, and careers. When someone dares to challenge the consensus, to propose ideas that threaten the comfort of established thought, the reaction can be brutal. Avi Loeb has lived this firsthand. He's not the first scientist to be ostracized for unconventional ideas, and he won't be the last, but the intensity of the backlash against him, first with Oumuamua and now with 3I Atlas, exposes something deeply uncomfortable about how modern science handles anomalies that don't fit neatly into existing frameworks. Let's start with NASA's response. Tom Statler, NASA's lead scientist for small solar system bodies, was asked if 3I Atlas could be alien technology. His reply was dismissive. He told reporters that 3I Atlas looks like a comet, acts like a comet, and very strongly resembles comets we already know. He admitted it had a few curious properties, but concluded that the evidence overwhelmingly points to a natural body. At first glance, that sounds reasonable. Most anomalies do turn out to have natural explanations. Extraordinary claims require extraordinary evidence, and so far, the case for 3I Atlas being artificial is circumstantial. But notice what Statler didn't explain. The nickel without iron, the precise trajectory alignment, the timing coincidences, the mass problem, the anti-tail, all ignored. He simply said, "It looks like a comet," and left it there. This is a familiar pattern. When scientists want to dismiss an uncomfortable idea, they fall back on generalities. It looks normal. It behaves as expected. The alternative is too wild. But when you actually look at the data, the details refuse to fit that simple story. And weird deserves explanation, not dismissal. Jason Wright, an astronomer at Penn State University, has been more direct. He runs a blog called Astro Wright, where he often critiques other researchers' papers. He's written multiple posts dissecting Loeb's arguments about 3I Atlas, and his tone is cutting. In one post, Wright accused Loeb of ignoring evidence that contradicts his hypothesis. He pointed out that Hubble's images clearly show a coma, that glowing cloud of gas and dust that defines a comet. Loeb acknowledged it, but argued the distribution was unusual, brighter in front than behind. Wright called that reasoning a mistake bigger than ignoring the images altogether. He also attacked Loeb for pushing the alien hypothesis even after spectroscopic data from Webb and the Very Large Telescope showed 3I Atlas venting carbon dioxide, water, and cyanide. To Wright, that confirms it's a comet. Why would an alien spacecraft vent water vapor and CO2? The simplest answer, it's a sublimating body, not a machine. Loeb's counter-argument. The composition itself is strange, 95% carbon dioxide. Nickel without iron, that's not normal. Just because something vents gas doesn't mean it's natural. It could be a spacecraft coated with ice and dust from eons of travel through interstellar space, outgassing as it warms. mimicking a comet while concealing the technology beneath. Wright finds that unconvincing. He says Loeb is stacking speculation on speculation just to keep his theory alive. He even compared Loeb's logic to conspiracy theorists who demand others prove them wrong instead of providing solid proof themselves. In Wright's view, the burden of evidence lies squarely on Loeb to prove it's artificial, not on others to prove it isn't. Then there's Steve Desch, a planetary scientist who reviewed one of Loeb's papers and called it sloppy work beneath undergraduate level. He literally graded it like a failed student essay. He accused Loeb of cherry-picking data, ignoring alternatives, and building conclusions on weak assumptions. This wasn't ordinary academic critique, it was personal. It crossed the line from disagreement to contempt. And that raises a question. If Loeb is so wrong, why the need to humiliate him? Why not simply ignore his work? The answer may lie in influence. Loeb's ideas get attention. The media covers him. The public listens. And when the public gets excited about ideas the mainstream rejects, scientists feel a duty to push back, to correct the record, to keep control of the narrative. But there's another layer here. Loeb isn't some fringe amateur. He's a Harvard professor, former head of the astronomy department, a highly cited academic. He was the establishment, and when someone from inside the system starts questioning its foundations, it threatens that system's authority. Science thrives on testing new ideas, but it also protects its boundaries. That resistance serves a purpose. It filters out nonsense, saves time, and preserves credibility. But it can also smother innovation, delay discovery, and punish those who dare to take risks. Loeb's papers on 3I Atlas have hit walls again and again. One paper he co-authored with Eric Keto, offering a physical explanation for the object's anti-tail, was rejected by a journal editor who said the results were of limited interest. Translation: we don't want this published. Another paper, about the object's mass and lack of gravitational acceleration, was delayed for days on the arXiv preprint server. No explanation given. It finally appeared, but the silence spoke volumes. Coincidence? Maybe. Or maybe a quiet effort to slow Loeb down, to let mainstream scientists prepare their rebuttals before the story spreads. Loeb himself has responded to the criticism directly. He says science should be driven by curiosity, not conformity. That anomalies aren't threats, they're opportunities to learn. History agrees. Continental drift, the Big Bang, black holes, all ridiculed at first, all later proven true. He points out that his critics rarely address the data itself. They say it's a comet, but ignore the nickel. They say it's random, but skip the math. They call him speculative, yet overlook that his speculation is grounded in physics and evidence. And then there's the personal side. Some of Loeb's critics haven't just attacked his ideas. They've attacked him, his credibility, his character, and that says more about them than it does about him. They've questioned his motives, accusing him of chasing fame, of lending legitimacy to fringe theories, of harming science itself. An editor who handled one of his papers publicly mocked him. And when Loeb protested, the editor's superior defended it, calling the behavior not unethical. This is academia, devouring its own. When a field feels threatened by unconventional ideas, the response can be brutal. Reputations are everything, and they're fragile. If you're branded as the person who backed a wild idea that proved wrong, that mark never fades. So, most scientists protect themselves. They steer clear of risk, and they turn on anyone who doesn't. But what if Loeb is right? What if 3I Atlas is artificial, and the scientific world dismissed it because it was too disruptive, too uncomfortable, too far beyond the accepted boundaries of thought? The cost of that mistake would be staggering. We would lose our chance to study, to prepare, to understand. And someday, future generations might look back and ask, how could we have been so blind? Chapter 9, What If We're Wrong? The Natural Explanation Attempt. Let's be fair to the skeptics. Let's build the strongest possible case for 3I Atlas being a natural object. Because, statistically, that's still the most likely answer. Extraordinary claims demand extraordinary proof. And while the anomalies are fascinating, they're not yet proof. Science demands we weigh every possibility, and the natural hypothesis deserves its chance. Start with chemistry. 95% carbon dioxide, 5% water. Strange, yes, but strange doesn't mean impossible. Comets form in diverse zones of their birth disks. Different temperatures, pressures, compositions. A comet formed farther out, where CO2 ice is more stable than water ice, could easily be rich in carbon dioxide. Then there's the cosmic ray cooking idea. 3I Atlas may have drifted through interstellar space for billions of years, its surface endlessly bombarded by cosmic radiation, breaking molecules apart, forging new ones. Over time, water ice can be transmuted into carbon dioxide through a process called radiolysis. The outer layers could have become CO2 heavy, while the interior stayed rich in water. As sunlight warms the surface, deeper pockets vent gas through cracks, creating the activity we now see. Comets aren't uniform, they're patchwork worlds, filled with layers and voids, each region reacting differently to heat. Now, the nickel without iron issue. A harder nut to crack, but not impossible. The VLT team suggested nickel carbonyl, a molecule born when nickel meets carbon monoxide. It's highly volatile, vaporizing at very low temperatures. If 3I Atlas harbors nickel carbonyl, perhaps created in its parent system, or along its long cosmic journey, that could explain nickel's presence without iron. Iron might simply be trapped in tougher compounds, iron oxides, sulfides, or silicate minerals that need far more heat to break apart. So as the comet gets closer to the sun, nickel appears first. Iron may follow later, once temperatures climb high enough to release it. Then there's the orbit. Its alignment with the ecliptic plane, 1 in 500 odds. Sounds rare, but with enough samples, even rare alignments happen. Over decades, as we detect hundreds of interstellar visitors, we'll surely find a few that align just so, purely by chance. The timing, though, passing near Mars, Venus, and Jupiter. 1 in 20,000 odds. That's harder to shrug off, but selection bias might play a role. Objects that pass near the ecliptic, closer to Earth, shine brighter, making them more likely to be discovered. Perhaps our methods are skewing the statistics, the size difference, the mass problem. 3I Atlas is much larger than the two previous interstellar objects, but maybe that's just population diversity. Small ones like Oumuamua and Borisov could be common, large ones rare. We've only found 3 so far, too few to map a pattern. And the anti-tail, that strange forward glow, that too could arise naturally. If the nucleus rotates slowly, and most of the venting happens on the sunward side, a plume could expand forward, scattering sunlight in just the right way. If dust output is low, or the grains are heavy enough, they won't form a long trailing tail. So every anomaly has a potential natural cause. Yes, they may require rare chemistry, unusual conditions, or statistical flukes, but not impossibilities. And when faced with 2 ideas, one rooted in known science, and one invoking alien technology, Occam's razor whispers the answer. Choose the simpler path. The simpler path says, 3I Atlas is a comet, a strange ancient traveler from another star, forged in the cold and shaped by time. Not a machine, but a relic of cosmic history, born from nature's own hand. This is the stance most astronomers take, and it's a fair one. It acknowledges the anomalies, but reminds us that extraordinary claims require extraordinary proof. And so far, that proof simply isn't there. We have patterns that suggest, coincidences that intrigue, but no smoking gun. No unmistakable evidence of structure, propulsion, or intelligent design. Upcoming observations, from late October through November, will deliver crucial data. The Perseverance images from Mars, the spectral readings from ESA's orbiters, and continuous monitoring as the object swings around the Sun and re-emerges. Each new dataset will test the theory. If everything fits the comet model, if 3I Atlas behaves predictably and no new anomalies appear, then the technological hypothesis fades into silence. But if something strange happens, if it defies the behavior of a normal comet, if the unexpected continues to surface, then the conversation must reopen. And that's all Avi Loeb is really asking for. Not blind acceptance of his idea, but the courage to keep an open mind, to follow the evidence wherever it leads. There is a middle ground, between shouting aliens at every mystery and refusing to see possibility at all. That ground is honest investigation, without prejudice or pride. It's saying we don't know yet, but we're going to find out. The universe, after all, loves to surprise us, and some of those surprises can shake our understanding to its very core. One argument stands out: the age of 3I Atlas. If it truly came from the Milky Way's thick disk, as its velocity and trajectory imply, it could be 7, even 11 billion years old, older than our Sun, older than Earth, older than nearly every object in our solar system, an object that ancient has seen everything. It's watched stars ignite and die, passed through violent radiation zones, and drifted through the galactic fog for eons. Over all that time, it's been scarred, reshaped, and transformed in ways we can barely imagine. Its crust battered, its chemistry rewritten, its interior remade by forces that have long since faded from our corner of the galaxy. When something has endured that long, you can't expect it to behave like the comets we know, mere infants at 4.5 billion years old. Its makeup could be different. Its physics could be different. Everything about it could defy what we've come to expect. So maybe the anomalies aren't signs of technology. Maybe they're signs of unimaginable age, of origins stranger than anything we've studied before. Maybe 3I Atlas is reminding us that nature is more inventive than our models allow, that reality still has surprises left to teach us. Perhaps the real lesson here is humility, an acceptance that our understanding of comets and interstellar objects is still in its infancy. And that lesson alone would be profound. It would expand our knowledge, make us better scientists, and it wouldn't require rewriting our entire worldview or facing the thought that someone out there is watching. Chapter 10. Humanity's Crossroads. What happens next? We are approaching a moment of clarity. In the coming weeks, multiple spacecraft will turn their eyes toward 3I Atlas with unprecedented precision. The Mars flyby on October 3rd will bring our first close-up images. The perihelion passage on October 29th will test whether it behaves like a comet or something else entirely. Then, as it re-emerges in late November and December, we'll see whether its path has shifted. Every observation is a test. Each one will confirm or challenge what we think we know. Between November 2nd and November 25th, ESA's Jupiter Icy Moons Explorer, better known as JUICE, will focus its instruments on 3I Atlas. The spacecraft, on its way to Jupiter after Earth and Venus flybys, is perfectly positioned to watch the object in one of its most active phases. Right after perihelion, when sunlight is at its most intense, JUICE carries cameras, spectrometers, and a particle detector. Its cameras will map the glowing coma and any tail that forms. Its spectrometers will dissect the light, searching for molecules missed before, and the particle detector will measure ions, tracing how the solar wind interacts with the escaping gas and dust. ESA believes JUICE will have the best possible view of 3I Atlas in its most active, volatile state, a time when surface layers peel away, revealing whatever lies beneath. If there are hidden structures, if anything artificial is concealed beneath the dust, this is when we'll see it. The full dataset, however, won't reach Earth right away. JUICE is currently behind the Sun, using its main antenna as a heat shield. It's communicating slowly through a smaller dish, so the data won't be downlinked and analyzed until February 2026, months away. But when that data arrives, it could answer the question once and for all. There's also talk of coordination between JUICE and NASA's Europa Clipper mission. Both carry ultraviolet spectrographs, instruments capable of detecting atoms and molecules by their faint ultraviolet glow. If both craft observe 3I Atlas simultaneously from different angles, they can triangulate the gases, building a full 3D map of its outgassing behavior, a level of detail never before achieved for any interstellar object. And now comes the question everyone is silently asking. Should we try to communicate? Should we send a message, a signal, to 3I Atlas if it truly is artificial? Avi Loeb has written about this dilemma. He warns of two main risks. First, we don't know who or what might be listening. If this object is a probe from an advanced civilization, our message could be seen as a threat. In the dark forest view of the cosmos, to reveal yourself is to invite danger. Broadcasting a signal that says, "Here we are. We're intelligent. We exist," might not sound bold, it might sound dangerous. To an unknown intelligence, that message could be read as a challenge, or even a declaration of hostility, and the response could be violent. Even if their intentions aren't hostile, communication itself could go wrong. A message meant as curiosity or friendship could be twisted by misunderstanding, because language, even mathematics or imagery, is never neutral. It carries assumptions, context, and culture, an intelligence born of a completely different world, with different senses, different ways of thinking, different biology, could interpret our words in ways we can't predict. A friendly greeting might sound like an insult. An offer of cooperation might look like surrender. But then again, what if 3i Atlas was built to listen? What if it was sent here to seek out signs of life, and it's waiting for an answer? If the wow signal truly came from this object, then maybe it wasn't just a burst of static across space. Maybe it was an invitation, a test to see if anyone was out there paying attention. And by staying silent, we may be missing the chance of a lifetime, the chance to make contact, to learn, to access knowledge far beyond anything humanity has ever known. Avi Loeb suggests we take a cautious approach. Before speaking, observe, treat it like a cosmic first date. Watch how it moves, learn its behavior, its nature, its intentions, before saying a single word. If 3i Atlas begins to maneuver deliberately, if it reacts to being watched, if it shows even a hint of awareness, then, and only then, should communication be considered. Because rushing to speak without knowing who or what is listening could be reckless. When humanity sent the Arecibo message in 1974, it was aimed at the globular cluster Messier 13, 22,000 light-years away. Even if someone there heard us, the round-trip reply would take 44,000 years. There was no real danger, but 3i Atlas is different. It's here, inside our solar system. If it can receive and respond, we wouldn't wait millennia. We'd wait months, and that changes everything. We have to think carefully about what we send and what consequences might follow. And there's another possibility, one even more unsettling. What if we're not the first? What if 3i Atlas has already been communicating with something else? What if other probes, older, hidden arrivals, are already here, coordinating quietly across the solar system? The wow signal might not have been aimed at Earth at all. It could have been a message between machines, a transmission we overheard by accident, a conversation never meant for us. If that's true, then the real question isn't whether to communicate, but whether we should admit we were listening. Maybe the smartest move is to stay silent, to observe, to learn as much as we can without announcing ourselves. The Galileo project plans to do exactly that. After October 29th, Loeb's team will be watching for any rise in unidentified anomalous activity. If 3i Atlas truly is a mothership, and if it releases probes, those fragments might soon appear in our skies, entering Earth's atmosphere, or maneuvering silently in near-Earth space. And if that happens, then the greatest discovery in human history may already be unfolding, right above us. The Galileo observatories are built for moments like this, to detect, track, and study what shouldn't exist. If 3i Atlas truly reveals alien technology within our solar system, then that discovery alone would eclipse every scientific breakthrough in human history. It would answer the question that has haunted humanity for centuries. Are we alone? And if not, what kind of civilization has found us? A species capable of interstellar travel, reaching across the void, and choosing to come here. But detection is only the beginning, because once we find it, then comes the decision no one is ready for. Do we try to intercept it? Do we communicate? Do we prepare defenses? Or do we stay silent and observe? These are not choices for one nation or one scientist. They belong to all of humanity, to physicists, philosophers, strategists, and everyone who dares to look up at the night sky. Yet, we have no plan. There is no global framework, no unified command, no single voice that speaks for Earth. The United Nations manages treaties and orbits, not first contact. SETI has protocols for radio signals, not for alien craft drifting through our solar system. If contact happens tomorrow, our response will be chaotic. Nations will argue, militaries will posture, scientists will scramble. Some will want to reach out, others will demand silence. And in that confusion, we might lose our greatest chance, or trigger something we can't control. That's why Loeb proposes a new kind of organization, an international body tasked with monitoring interstellar objects and creating response protocols. Each object would be ranked on a scale, from harmless natural visitors to confirmed technological anomalies requiring global coordination, because soon, detection won't be rare. The Vera Rubin Observatory is about to begin full operations, and it will find dozens, perhaps hundreds, of interstellar visitors each year. Each one could be a relic of ancient worlds, or a messenger from another civilization. We need that framework before the next discovery, because 3i Atlas might only be the first. If it's natural, we'll still learn something extraordinary about ancient comets, about the birth of other solar systems, about how matter travels between the stars. But if it's not, if it's something built, something sent, then everything changes. It would mean intelligence beyond Earth exists, and it has found us. Religion, philosophy, science, politics, nothing would remain untouched. Humanity's self-image would shatter, reborn under the weight of cosmic truth. And now, as September fades into October, the world waits. Telescopes are turning, data streams are flowing, and somewhere beyond the orbit of Mars, 3i Atlas continues its silent approach, carrying questions older than civilization itself. Is it a messenger, a machine, a relic, or something we're not yet ready to name? The beauty of this moment, the reason it matters, is that we face it together. Every telescope, every observer, every person listening to this story, we're all part of a single, shared awakening. A reminder that curiosity is what defines us. That courage is what carries us forward. I think of Jerry Eman in 1977, staring at the WOW signal printout, seeing something that shouldn't have been there, and scrawling one word in red ink. Wow. He didn't know what it meant, but maybe now, we're about to find out. Whether 3i Atlas is a comet or a craft, a wanderer or a watcher, it has already given us something priceless, a reason to look up again, a reason to question everything we thought we knew, because the universe doesn't care about our comfort, our theories, our limits. It simply is. Vast, silent, and full of wonders we've barely begun to understand. Soon, data from Mars and solar observatories will pour in. We'll watch as 3i Atlas vanishes behind the sun and hold our breath, waiting to see if it reappears. If it does, perhaps the story of humanity's isolation ends there and a new chapter begins. And if it doesn't, we'll still have learned, because seeking answers in the dark, that's what it means to be human. So as the days count down, keep your eyes on the night sky. Stay curious, because somewhere above you, moving silently through the void at 60 kilometers per second, an object from another star is closing in on our sun. And what happens next might redefine what it means to be alive. This isn't just science fiction anymore. This is the moment history starts watching us back. Keep watching the sky.